Let's go. So these will be a little tougher ones. Like the first one I do, that can be test level. The second one, not so much. Okay? But the second one you're going to need to know to do your homework. It's just one problem. But we're going to keep using the same idea. Okay, just jumping right in. Let's go prove that. Let's say the limit is x tends towards 3 of the absolute value of x squared minus 6x plus 10 is equal to 1. Oops, why am I using absolute values? There we go. We're going to go prove this. So jumping right into it, our first step is we're going to write it as 0 is less than x minus our a value, which is going to be 3, which is less than delta. Well, that implies that the absolute difference between f of x and its limiting value is less than epsilon. Okay. We're ready to go, and let's go find delta. Let's go find that delta. So we're going to take our absolute value of x squared minus 6x. Now while we're doing this, 10 minus 1 is not positive 9. It's less than epsilon. I'm not going to write that in. Just it saves us a step, right? You don't want to write it over and over. Let's factor that sucker up, and I think that's just going to be x minus 3 all squared inside that absolute value, which is less than epsilon. Now, do you think it matters whether the square is on the inside or the outside? The absolute value is always positive, right? Well, it's never negative. That's more accurate. Is a square ever negative? Not when we're dealing with real numbers. So what we can actually do is just yank the square to the outside. We can say the absolute value of x minus 3 all squared is less than epsilon. And we do that because, look, the absolute value of x minus 3 is less than delta. That's a great thing. So let's hit both sides of this. What do you think? What's the opposite of a square? Before we had like a number times it. So we divided, right? Because the opposite of multiplication is division. That's why I divided the number over. We're going to do the opposite of the function. What do we do? The opposite of a square is a, hell yeah, it's a frickin' square root. So the absolute value of x minus 3 is less than the square root of epsilon. Bang, bang, bang. There it is. That's a perfect square. This one works out nicely. Typically, I won't mess with you with squares. This one, shit, let's go. Let delta equal the square root of epsilon. It's perfect. Yeah. That absolute value of x minus 3 less than delta. The absolute value of x minus 3 less than our delta. It's right there. Now let's do the proof. Let's finish this sucker off. All right, so our proof. There it is. Let's go get it. So we are going to say the absolute value of x squared minus 6x plus 9. What's that shit equal to? What's that equal to? That's equal to, well, I'm jumping from here to here. X minus 3 all squared. Now here it comes, because we're about to sub in. We got to do the delta before we do what delta equals. We got to sub that thing in. So we're going to say that this thing is, we got to go less than delta. And we leave that square in there. So we didn't replace the square part. We just replaced the absolute value of x minus 3 with less than delta. And now we can write in what delta equals. Delta equals the square root of epsilon. And the square root of something squared is equal to epsilon. So we just showed that the difference between f of x and our L is less than epsilon as long as we have delta to equal the square root of epsilon. Therefore, the limit as x tends towards 3 of x squared minus 6x plus 10 is absolutely equal to 1. And there's a perfect square. I could test you on something like that. I think that's fair. That's in your homework. It's good. Most certainly. Now let's get on to the one that this is a little much. I wouldn't put this into your test. This one is going to be long. All right, here it is. And it looks so innocuous, harmless. It looks so harmless. We want to prove that the limit as x tends towards 1 of x squared plus 1 is equal to 2. Shit, that looks simple, right? That one looks easier than the last one. It's not. This one's jacked up. Let's go. So we're going to write it in that if we keep our the absolute difference between our x and 1 is less than delta, it implies that the absolute value of x squared plus 1 minus 2 is less than epsilon. So that's our problem. And we started there. This one's not going to work the same way. So here we go. We did our first step right here. Now let's move on to part 2. Here comes the weird. When we go to find our delta, shit's going to get weird. So here we are. We're going to be like, okay. We got our x squared. And then what's that? Minus 1. The absolute value of x squared minus 1 is less than epsilon. Okay. Just put those two things together. And then we go down and we're like, well, wait a second. That difference is squares. That's x plus 1 times x minus 1 inside that absolute. Okay. Less than epsilon, and then, oh, shoot. There's two of them. And what this is, the absolute value of x plus 1 times the absolute value of x minus 1 is less than epsilon. Crap. Here's what we're going to do. Whichever one looks like delta, this is going to be a two-step process over on the side. Two-step. And it's weird. It's funky. We're going to let whatever one looks like the one that's next to delta, or x minus 1, or take this, the absolute value of x minus 1. And we're just going to say, let's let it just be less than 1. That's choosing, this is essentially just choosing delta to equal 1. We're going to choose the minimum of two things. So there's the two-step process. We go, boom. We let it, there's number 1. We let it, the one that's next to delta, and we just set it less than 1 every time. Now you can choose 17 if you wanted to. Please choose 1. For God's sakes, please choose 1. It's going to make your life so much easier. And the second step is we want to make the absolute value of x minus 1 look like the absolute value of x plus 1. You're like, what? Actually, take the absolute values off. We want the one on the, we want this shit to look like this. Okay, so that's going to be the game. We're going to do a little bit of manipulation. So here it comes. So there's the steps, and that's what we're going to do. Now let's go mess with it. So we say the absolute value of x minus 1 is less than 1. That's from up above. Now let's take those absolute values off, and we say negative 1 is less than x minus 1 is less than positive 1. Well, we want to make it look like x plus 1. Now this is so weird. We're not solving for x. We want this to be x plus 1, not x minus 1. So what will we have to add to negative 1 to make it positive 1? We'd have to add 2. So now let's look at this. We have 1 is less than x plus 1, which is less than 3. Yeah, buddy! We made x minus 1 look like x plus 1 inside of something. And now what we're going to do is we're going to take whatever frickin' one is bigger in magnitude. What's bigger in magnitude, 1 or 3? 3. And we're just going to use this. We're going to say, let's go. We're going to let this shit go. We're like, you know what we can do? We're going to use the upper bound. The upper bound. Whatever's bigger. Now, if this was going to be negative 1 and negative 3, we'd still choose the negative 3 and call it positive 3. So here's what we're going to do with it. Whatever we find this number to be, we're going to just take it and go, boom, and replace that x plus 1 with it. So it's 3 times the absolute value of x minus 1 is less than epsilon. Holy shit, huh? Now divide by that 3 and you get that x minus 1 is less than epsilon over 3. And you might be like, dude, we already found delta. We said it was 1. We're actually going to look at the minimum. So we have this epsilon over 3. So we have this delta could also equal epsilon over 3. Here's our third step. I told you this one's a mother, huh? You're like, oh my gosh. Oh my gosh. I won't do this and make you do a written one, but you will have to read through one in your homework. So here's what we're going to do. We're going to let delta equal the minimum. There's my curly brace. That was nice. Yeah, that's not much better. 1 and epsilon over 3. 1 and epsilon over 3. Those two choices. It's always going to be 1 whenever you figure it out to be. Like, never mind. So we go through. We're good. We're good. So what we're going to do is, while we're going to choose the minimum, we're not going to mess with the 1. I'm going to let you in on a little secret. Math majors, send me a message. I'm down. I'll go through and I'll explain the whole reason why that this is all going to work. But I'm just going to jump right out of it, and we're going to go into the next part. We're going to take that absolute difference. That what was our problem? It was x squared plus 1 minus 2 is less than epsilon from up above. Remember that? Remember that part? So we're going to take that, and we're going to manipulate it again. So we're going to say this is equal to, and this is equal to what? The absolute value of x plus 1 times the absolute value of x minus 1. Cool. Now we stated that, oh shoot, this needs to be less than. This needs to be less than, because our, remember this? The absolute value of x plus 1 less than 3? We gotta put that thing in there. We're gonna put that thing in there. We're just gonna go 3 times the absolute value of x minus 1. And that's okay. We're gonna have a couple of these things in there. Now our next one, we want to replace that absolute value of x minus 1. The absolute value of x minus 1, but now here comes the frickin' weird. When we do this, we need to write a less than or equal to sign. Because we're not sure whether it's going to be 1 or epsilon over 3. Math majors, let me know if you want to know more about it. The rest of y'all just follow the rules. And we're going to say that this is 3 times, and we can pop in our delta. And now we're going to choose this one. That's going to make everything work out oh so freaking nice right now. Oops, actually, I missed a step. I did it at the wrong time. This one doesn't get the equal. Come on, I suck. Just less than delta. The absolute value of x minus 1, that's just less than delta. Why am I changing the rules on you? Shit, that was wrong. Oops. It's the next step. It's this one that needs the less than or equal to, because we're not sure whether the delta is going to be 1 or epsilon over 3. It could actually be equal to that number. So we get 3 times our epsilon over 3. It cancels, and gives you your epsilon. Therefore, the limit as x tends towards 1 of x squared plus 1 is indeed equal to 2. Yeah. Math majors, you need to know this. Anybody else needs to know this shit. But you do have a problem. It's the last problem in your 2.4 homework. This is how you were going to do it. Follow along. It's all the same rules. I will see you in 2.5.